This is section 1.4, and it's about using the definitions of the trig functions and beginning to get some basic identities. And these are things that you're going to eventually need to know, so start memorizing them now. You'll just use them forever in this course. So we've talked a little bit about the reciprocal identities. So sine theta is equal to 1 over cosecant, cosine is equal to 1 over secant, and tan is 1 over cotan. And then you can flip those and get these same things down here. So those are the first basic ones to start learning. When we're working with our calculator, we want to be sure that we are in degree mode for these. And in trig, it's really important to check your mode at times, because as we begin to go further, there'll be times when we want to be in radian mode. But for now, we want to be in degree. So if you were finding the cosecant of 90, let's go here. Let me get my calculator up here. So mode is right here on your calculator, and mine is in degree mode. So I just wanted to check it's right over here, but I could change it to radian if I needed to. So let me quit out of that. And if I wanted the sine of 90, I could just hit my sine key and hit 90 and enter, and I get a 1. But if I want cosecant, I need to do 1 divided by sine 90 and enter. And in our case, we still get 1. But that's how you could do those reciprocal relationships. So now let's go down. This is another thing that's really, really important. And it's about where are our trig functions positive and negative. We're talking about going around the unit circle here. And you see that I've got these letters written, A, S, T, C. And you can remember that if you remember the acronym, all students take calculus. So if you can write that down and start to remember it, if you're in a face-to-face class and you're going to take a test, I would write that down if you think you may need it once you get your test. So in the first quadrant, all the functions are positive. All. In the second quadrant, it's sine and it's reciprocal, so sine and cosecant are positive, everything else is negative. In the quadrant 3, it's tan and cotan are positive, everything else is negative. C is for cosine and it's reciprocal secant, they're positive, everything else is negative. This will be really important because the sign, the S-I-G-N of a number, is imperative in trig. You need to know whether something is positive or negative. All right, now let's talk a little bit about what sine curve looks like. And we're just doing a little bit right this moment, but we'll get far more into that. But sine theta and cosine theta fall between -1 and 1. So here's what the curve looks like. They don't go lower than -1. They don't go above 1. If you tried to take the sine of, let's do sine, let me do it this way. Let me clear that. Second sine of 2, which says what angle has a sine of 2? I should get an error because it can't exist there. So that should show you that. All right, let's go back here. So that's, and then the secant and cosecant, those actually look like these little pieces up here. And so they're either less than -1 or greater than 1. It's these little curves up here. And then tangent, they go like this, and they don't have any range restrictions. They go -infinity to infinity. They do have some issues on the x. So now let's look at a few more identities. These are the Pythagorean ones, and they're really important too. Particularly, you'll see this one a lot, but we do need to know these. And so sine squared plus cosine squared equals 1. And if you saw it in a different way, so if I subtracted the cosine squared theta over here, I would have sine squared is equal to 1 minus cosine squared. So you could get these two out of this one. And then we have tan squared theta plus 1 equals secant squared. 1 plus cotan squared theta equals cosecant squared. So these are the Pythagorean. We need to begin to learn those as well. The quotient identities, there's two of those. Tan is equal to sine over cosine. And since if you flip tan, you get cotan, then you could flip this and you get cosine over sine. Those come into play a little bit later, but they're important as well. I believe that's our information for section 1.4. Let's go look at our problems. So number 1 says select the correct choice that completes the sentence. If sine is greater than 0 and tangent is greater than 0, then what quadrant is theta in? So both of these things have to be true. Well, remember our little all students take calculus? Well, sine is positive in quadrants 1 and 2. Let's go back and look at our, here. So sine is positive here, and tangent is positive here and here. So when we go back over here, it's quadrant 1 and quadrant 3. Well, where's the overlap? It's here in quadrant 1. So that's our answer. That's how we'll be able to figure out that one. Number 2 says decide whether this is possible or impossible. If sine is 1/5, then cosecant would be 5 over 1. Those are reciprocal relationships, so that is possible. Sine can be 1/5, cosecant alpha could be 5 over 1. Decide whether this is possible or impossible. Tan is -6 and cotan is -6. Well, since tan and cotan are reciprocals, then that can't be true. They can't be the same thing, so they have to be flipped. So that statement is impossible because they're reciprocals of each other. Can cosine theta equal -1.2? Remember we said that cosine cannot be below -1 or above 1. So since -1.2 is below this, that is impossible because of the range, and the range is from -1 to 1. All right, number 5, use the appropriate reciprocal identity to find the exact value of secant for this. Well, if cosine's 2/3 and they are reciprocal, then secant would be 3 over 2. We would just flip it. What is the exact value of sine if cosecant is square root of 12 over 3? Well, we have to flip it. 3 over square root of 12. Then we have to rationalize. We can't leave the radical down here. So square root of 12 over square root of 12. Multiply across. So you have 12 down here. You have 3 square roots of 12 here. And then that simplifies. 3 goes into 12/4. So we have square root of 12 over 4. Now, where did I get this 2 square roots of 3? Well, if we go over here and look at square root of 12, that's equal to the square root of 4 times the square root of 3. Square root of 4 is 2 square roots of 3, so that is more simplifying. When we do that, then this 2, and this 4 can simplify, and you just have 2 on the bottom. So we have square root of 3 over 2 would be our answer. Okay. Number 7, if cosecant is 2.0221875, what is sine? And so you can just do 1 divided by and put that number in your calculator, and you get the correct answer. It says round to 4 places. Number 8, find the sines of the 6 trig functions for the given angle. So let's think about it. What quadrant is 34 degrees in? Remember, we are 0 to 90, so we're in quadrant 1, and all things, all the angles, all the trig functions are positive. So you would just have pluses everywhere. Now, how about 304? 304, if we do this and we think about where 304 is, we know here's 270, so we're somewhere over here. We're in quadrant 4. What's positive there? Cosine and secant. Everything else is negative. So I've put cosine and secant were positive, the others were negative. So you really have to just figure out which quadrant you are in to answer these. 10, negative 211. So remember, we start here, and if we go all the way to here, we've gone 180. And so it'd be somewhere in quadrant 2. What's positive there? Sine and cosecant. So we've got cosine, sine is positive, cosine's negative, tan's negative. And then down here, the cosecant is positive. So those are the only two, sine and cosecant, that are positive. Identify all the quadrants of an angle theta that satisfies the given conditions. Where is tan negative or less than 0 and cosine is positive? So tan is negative here and here. Cosine is positive here and here. So the only place where both of those happen is quadrant 4. So sometimes it's helpful to just draw it out and let yourself see it. Number 12, where is cosecant positive and cosine is negative? Well, cosecant's positive in the first and in the second. Cosine's negative in the second and the third. So quadrant 2 is where both of those things happen. Number 13. So this one says find the exact value of each of the remaining trig functions, rationalize denominators when applicable. So they give you that tan theta is 4 over 3 and it's in quadrant 1. So I always draw it, and it always comes out from the origin and then straight down to the x. So here's theta, 4 over 3. So y is 4, this is 3. You can figure out that r is 5. How did we do that? We said 3 squared plus 4 squared is equal to r squared. So we did that. 25 is r squared and 5 is r. So then when you have that, go ahead and do the first 3. You know, tan is 4 over 3. Cosine is adjacent over, so that's x over r, 3 over 5. Sine is opposite over hypotenuse, that's 4 over 5. Once you have those 3, you just flip them and you get these over here. Number 14, same idea, you're just going to have a little bit more to do with rationalizing. So cotan is square root of 3 over 7. It's still in quadrant 1, so everything's positive. So I drew my triangle. Cotan is, well, tan is opposite over adjacent, so cotan would be adjacent over opposite. So square root of 3 is going to be there, 7 is going to be there. When I square both of those, square root of 3 squared is 3, 7 squared is 49. I get square root of 52, and remember we can do that by saying square root of 52 is equal to square root of 4 times square root of 13. So that's 2 square roots of 13. That's how we got that. So that's your r. So I drew that in there. Then I went and said, okay, so sine is 7 over that. We've got to get rid of this square root of 13. We do that rationalizing. We don't have to do anything special to the 2. So I end up with 7 square roots of 13 over 2 times 13. So that's 7 square roots of 13 over 26. All right, now cosine is square root of 3 over 2 square roots of 13. Again, we're rationalizing the square root of 13 over square root of 13. We end up on top with square root of 39 over 2 times 13, which gives us the 26. Tan is 7 over square root of 3. We got to get rid of the square root of 3, so we do that. We end up with 7 square roots of 3 over 3. Now that we have those, we can just do some flipping. Cosecant, if our final, we can start with what our original was, and we can just flip it, and we don't have to do anything. If we start here, we end up with a mess. So start with your original, flip it, and you get that. And then secant, we're going to flip cosine. And so cosine was square root of 3 over this. We'll just flip it. We get rid of the square root of 3, and we have 2 square roots of 39 over 3. Cotan, we're just going to flip this one. So we have square root of 3 over 7, and we don't have to rationalize anything. So on those that have the radicals, you do have to do a bit of algebra, but just remember you can't leave a radical in the bottom. So I think that will get you ready for the 1.4 homework.